Have you ever looked up at the night sky and wondered why the stars seem to twinkle? They shimmer, they flicker, and sometimes they even appear to change colors. But why does this happen? Is it the stars themselves? Or is something happening in our own atmosphere that creates this mesmerizing effect? Welcome to our deep dive into the fascinating world of atmospheric distortion and the science behind why stars twinkle. Let's start with the basics. When you gaze up at the stars, you are actually looking at distant suns many light years away. The light from these celestial bodies travels across vast distances of space in a perfectly straight line, but as soon as it reaches Earth's atmosphere, everything changes. The twinkling of stars, scientifically known as stellar scintillation, occurs due to the constant movement and varying density of our planet's atmosphere. The Earth's atmosphere isn't just empty space, it's a turbulent ocean of air, filled with different layers of varying temperatures and densities. As light from a star enters the atmosphere, it passes through these shifting air pockets. Each layer bends or refracts the light slightly differently, causing it to change direction multiple times before it reaches your eyes. This results in the star appearing to flicker or twinkle. Think of it like looking at an object underwater. If you've ever observed how a stick appears bent when half submerged, or how objects beneath the surface of a swimming pool seem to wobble due to the water's movement, you've witnessed a similar principle. Just like water bends light, the Earth's atmosphere does the same, making stars appear to shimmer in the night sky. But wait, if you've ever looked at planets like Venus, Jupiter, or Mars, you might have noticed that they don't seem to twinkle as much as stars. Why is that? The reason lies in their apparent size. Planets, though still incredibly far away, are much closer to Earth than stars. Because of this, they appear as small disks rather than tiny pinpoints of light. When atmospheric turbulence distorts the light from a planet, multiple rays of light from different parts of the disk average out, making the planet appear steadier compared to a twinkling star. The degree of twinkling you see depends on several factors. Altitude of the star. Stars closer to the horizon twinkle more than those overhead because their light must pass through more of Earth's atmosphere. Weather conditions. Wind, temperature fluctuations, and humidity all impact the way light travels through the atmosphere. Light pollution. While it doesn't cause twinkling, city lights can obscure our ability to see stars clearly, making twinkling less noticeable in urban areas. Have you ever noticed that stars sometimes change colors as they twinkle? This happens because the Earth's atmosphere acts like a giant prism, splitting light into different colors as it bends. This effect is most noticeable in bright stars like Sirius, which often appears to flash between white, blue, green, and red hues. The scientific term for this color shifting is atmospheric dispersion. The twinkling of stars has fascinated humans for centuries. Ancient civilizations often attributed supernatural meanings to it, believing that twinkling stars were messages from the gods. The famous nursery rhyme, "Twinkle, Twinkle, Little Star," captures this very wonder. Even in scientific history, early astronomers like Aristotle and Ptolemy wrote about stellar scintillation, long before we understood atmospheric physics. For professional astronomers, twinkling is more than just a beautiful phenomenon, it's a challenge. The distortion caused by Earth's atmosphere makes it difficult to get clear images of celestial objects. To counter this, astronomers use techniques such as adaptive optics, a technology used in telescopes that compensates for atmospheric distortion in real time. Observing from space. Space telescopes like Hubble avoid atmospheric interference entirely by operating beyond Earth's atmosphere, choosing ideal locations. Observatories are built in high-altitude locations like Hawaii or the Atacama Desert in Chile, where the atmosphere is thinner and turbulence is minimal. You don't need expensive equipment to observe the twinkling of stars yourself. Here are some ways you can experiment. Compare a star to a planet. Try looking at a bright star like Vega, and then at a bright planet like Jupiter. Notice the difference in twinkling. Watch the horizon versus overhead. Observe how stars near the horizon twinkle more than those directly overhead. Use a telescope. A small backyard telescope can help reveal how atmospheric distortion affects celestial objects. The twinkling of stars is a mesmerizing sight. And now you know the science behind it. It's not the stars themselves that flicker, but rather Earth's ever-changing atmosphere that causes this visual effect. From ancient myths to modern astronomy, the mystery of twinkling stars has captivated human curiosity for generations. So, the next time you gaze up at a starry night sky, take a moment to appreciate the incredible science at play. And if you enjoyed this video, don't forget to like, subscribe, and hit the notification bell for more fascinating explorations of the universe. Thank you for watching. Keep gazing at the stars.